Let's jump right in. Welcome to this explainer on the foundations of human-AI interaction. Just think about your morning today for a second. You probably unlocked your phone with facial recognition, skimmed an inbox that was already pre-filtered by smart algorithms, and hey, maybe you even used a chatbot to summarize a super long document. The reality is, artificial intelligence has completely, seamlessly infiltrated our everyday lives. So today, we're going to unpack the mechanics, the history, and the profound ethical implications of this entire AI revolution. Think of this as a college-level lecture condensed into a highly focused journey, designed to give you the exact context you need to navigate our totally new reality. Here's our roadmap for today. First, we'll look at the evolution of AI. Then, how large language models work. Third, reshaping human-AI relationships. Fourth, navigating promise and peril. And finally, we'll wrap up with the PACE prompting method. Kicking things off with Section 1, the evolution of AI, looking back at a half-century of milestones. To really understand where we are right now, we have to trace our journey over the last 50-plus years of milestones. Back in the 1950s, we had symbolic AI and the famous Turing test. That test essentially asking if a machine could exhibit intelligent behavior indistinguishable from a human. Now, those early years, they relied on highly rigid, rule-based systems. Fast forward a bit to the 80s and 90s, and we see the rise of expert systems and machine learning. But the real modern explosion, the stuff we're dealing with today, happened relatively recently. In 2012, we saw massive, game-changing breakthroughs in deep learning, which finally allowed machines to recognize complex patterns like images and speech. Then, 2017 completely changed the game with the invention of the transformer architecture. By the way, that is literally the T in ChatGPT. And that architecture directly paved the way for the 2022 explosion of generative AI and the massive large language models we use today. So, here is the absolute most crucial takeaway. We are living through the most consequential shift since AI's inception, period. We're moving from machines that merely recognize patterns, like, sorting out your spam emails or finding a cat in a photo, to systems that are actively participating in human-scale creation. They can reason, they generate original code out of thin air, and they communicate fluently. This isn't just an upgrade, it's a fundamental shift in the technology's core capability. All right, moving right along to Section 2, how large language models actually work under the hood. Let's demystify the tech itself. It really boils down to a fascinating four-part process. First up, training data. These models ingest billions with a B of text tokens from the web, books, code repositories, you name it. And think of tokens simply as fragments of words. Next comes pre-training. This is essentially self-supervised learning, where the model practices predicting the next token in a sequence, over and over and over again. Then we apply transformers. These act as attention mechanisms. They capture long-range context, which is what allows the AI to actually remember what you said at the beginning of a paragraph by the time it gets to the end. Finally, generation. When you ask it a question, it uses probabilistic next token selection to generate a response. So when you get right down to it, it's essentially your smartphone's autocorrect, but operating on a massive, unimaginably complex scale, guessing the most statistically likely next word, just one at a time. Now, we absolutely have to separate the reality of AI from the hype. What large language models are, they're statistical pattern recognizers and probabilistic text completion engines. But here's where people really get into trouble. What they are not. They are not true reasoning engines. They are not infallible databases of absolute facts. And that right there is exactly why they hallucinate, or just make things up when they don't know an answer. And perhaps most importantly, they are absolutely not neutral or bias-free systems. They simply reflect the data they were trained on. Which brings us to Section 3, reshaping human-AI relationships, how we work, create, and decide. When we look at collaboration, we really need to start seeing AI as a co-creator, a thought partner, if you will. It's all about augmenting human judgment, not replacing it entirely. We call this human-in-the-loop decision-making. Because look, AI inherently lacks lived context, real-world experience, and ethical nuance, so human judgment is completely irreplaceable. A great example of this is AI-assisted research synthesis. You, the human, direct the inquiry, but the AI does the heavy lifting of gathering and organizing the information, which frees you up to make the higher-level strategic decisions. Then, on the automation side, we're delegating the repetitive cognitive tasks to AI. And this is creating massive workflow acceleration across almost all professions. Think about automated report generation, basic data entry, or scheduling. But as these repetitive tasks are handed off, we're seeing entirely new roles pop up that are focused strictly on AI oversight. Jobs like prompt engineers or AI ethicists, those didn't even exist a few years ago. But we really have to pause here because the human-AI relationship is deeply, deeply tied to power and ethics. Algorithmic bias can easily amplify existing inequalities. For example, facial recognition used in policing has shown some really significant flaws and biases that can inadvertently harm underserved communities. The hard truth is this: whoever controls the AI ultimately shapes who it serves. And right now, we are facing massive accountability gaps in how these systems are deployed in the real world. That leads us perfectly into Section 4, navigating the promise and the peril of AI across society. The question isn't whether AI will change society anymore. It already has. We're seeing massive impacts across the board. In healthcare, it's literally powering life-saving diagnostics and patient triage. In education, we've got personalized tutoring systems. In business, it's driving customer service and incredibly sophisticated risk modeling. But it also reaches into the unknown and, frankly, the dangerous. We're facing an era where deepfakes can perfectly mimic a public official's voice, where automated surveillance scales instantly, and where hyper-targeted misinformation campaigns can seriously disrupt public trust. These unknowns represent a profound shift in how we verify reality itself. So there's this critical tension right now. On one hand, the opportunities are staggering. We can democratize access to expertise, accelerate solutions to incredible societal problems like climate change, and free ourselves from repetitive drudgery. But directly across from that are severe risks. We've got encoded bias actively harming marginalized groups, disinformation eroding public trust, and major labor displacement happening before we've even built adequate social safety nets. Your job as an informed user is to recognize this tension and actively work to mitigate these risks while you harness the opportunities. Finally, Section 5, the PACE prompting method. This is your personal toolkit. So, how do you actually take control of these tools? Enter the PACE method. Think of this as your core structural framework. Because LLMs are probability engines, vague inputs produce vague and sometimes even harmful outputs. The PACE method gives us a structured, intentional language to make sure the AI produces safe, precise, and highly useful results for us. Let's break it down. P stands for problem. Clearly define the challenge you want the AI to address. A is for action. Specify exactly what you want the AI to do. C is for context. Supply the relevant background. And E is for expectations. Define what a successful output actually looks like. Think about the difference between a bad prompt and a PACE-engineered prompt. A bad prompt is just typing, "Write an email to my boss." The AI has no idea what you actually need. But using PACE, you'd say, "I need to request a deadline extension." Okay, that's the problem. "Draft an email." That's the action. "My manager is strict and the delay is due to a vendor issue." Boom, there's your context. Keep it professional, apologetic, and under 100 words. Those are your expectations. By using this framework, you transform from a passive user hoping for the best into an empowered engineer of your AI tools. To wrap up this explainer, I really want to leave you with something to chew on. Consider everything we've talked about today. The evolution from basic rules to probabilistic generation, the massive potential for collaboration, the urgent realities of encoded bias and labor displacement, and of course, your new toolkit for controlling these systems. I want you to ask yourself this final, vital question the very next time you sit down at your keyboard. What does it mean to you to use AI responsibly? Take a second and really think about it. Thanks so much for joining me on this deep dive, and keep learning.